guys, welcome back to my channel. So in this video I'm gonna go over a new section which is 9.7, which is about curl and divergence. Okay, so for those of you who are here to know the trick to find this equation, I'm gonna show the trick later. Right now I'm just explaining how did this equation come from. Okay, so to find the curl of a vector function, we have to cross product the gradient vector times cross producted with the function, and the function needs to be written in the form of p I hat, q j hat, and r k hat. So you know a vector function, right? So vector function is in terms of x, y, and z, right? So here you have it's written in the form of like xi hat and then yj hat plus ek hat, like that. So you're going to assume the I hat, j hat, and k hat in terms of p, q, and r over here. Okay, and then you're going to cross product that with the gradient vector. Gradient vector, you guys remember, it's simply the partial derivative with respect to x, with respect to y, and with respect to z. Okay, so you're going to take the gradient vector and then cross product it with the p, q, r over here, the function p, q, r that you assumed over here, and then you are going to do the cross product like we do normally. So we cross out the I hat first, right? Cross out the I hat, and then we're left with this partial derivative with respect to y and z, and then q, r. And next, since we're at j hat, remember it's always negative, so we cross out the j hat then, and we're left with this partial derivative with respect to x and z, and then p and r. And then afterwards we are going to cross out the k hat, and then we're left with partial derivative with respect to z and y and p and q. Next, what do we do next? So next, you guys remember what are we going to do? Next, we're simply going to cross product this. So this times this, and then negative this times this. Okay, so then this times this gives us partial derivative with respect to r with respect to y, and then q with respect to z. Okay, and we're going to do the same thing over here. So partial derivative of z x with respect to r, so we're going to multiply this and then negative this times this, so which is going to give you r with respect to x and then z with respect to p. Okay, so once you're done doing this, you are left with an equation over here which is going to let you find the curl of the function. And you can write this equation in a simpler way, because here it's looking very ugly. Okay, so you can write it in a simpler way, because partial derivative of r with respect to y can simply be written as r of y, and q with respect to z you can just write it qz. This simply means partial derivative of q with respect to z. And similarly the other cases like r with respect to x, p with respect to z, q with respect to x, and p with respect to y. Alright, so this was a lot of work to know the curl of the function, right? This is just the equation to find the function, but your next job would be to find these values and then plug in into this function to know the curl of the function. And this formula won't be given to you guys. You're gonna have to memorize it, because I remember my professor telling us that you guys need to memorize this formula, or you guys need to remember all these steps and derive this equation. But today I'm going to show you a trick, so you don't need to do all this step. Alright, so to find the trick, what we're going to do, first we're going to write p, q, and r. And like I explained you guys before, p is associated with the x variable, x component, right? And q is associated with the y component, and r is associated with the z component. So you're gonna write them side by side: p, x, q, y, and r, z. That's it, what you need to remember. And next, first of all, we are calculating for the I hat. So we're I hat represents p, right? So you're removing the p here, and then you're going to you guys remember how to calculate the determinant? Determinant is this times this and then this times this, right? So you're going to work in the opposite direction of the determinant. So you're going to start from the bottom and move it to the top. So this times this, and then you're going to do from top to bottom. And yeah, of course, putting a negative before doing the second step. So this times this and then negative this times this. Okay, so we're left with r of y negative qz. And then next we are moving on to the y direction. And in the y direction, we are going to put a negative g hat. Okay, so we are in the y direction. That means we are talking about the y component. That means we need to cross out the y component and the q, right? We need to cross out the q. And now working in the opposite direction of the determinant, which means multiplying this times this and then negative this times this. Okay, so r times x negative p times z positive k, and now we are working in the k hat. That means we're crossing out the z. Okay, so let's cross out the z then, which is the r. And now we need to work in the opposite determinant direction, remember? So we're multiplying q times x negative p times y. So q times x negative py. And lo voila, you guys see, you have the same equation. Okay, so it was as simple as this. Now let's do a problem so you guys don't forget how to use this equation. Okay, so here we have a problem. It says find the curl and divergence of a vector field whose function is given by this equation over here. And okay, so we are finding first of all curl over here. I'm gonna explain how to find divergence later. Okay, so we're calculating for curl right now, and the equation to find curl is right in front of us, but it's important to write this first, right? Otherwise you'll lose mark. So you guys just need to write like curl of f and gradient of cross product with f is equals to this equation. You guys need to write this because you guys need to show the teacher or the professor that you guys know what's going on. I had a friend, she didn't write all this and she lost marks for not writing this. So yeah, make sure to write it. Okay, so once we have written this, our next step is just to find what is missing, right? So first we need r of y, which means we are calculating the r with respect to y. And I explained you guys before, right, that what is p, q, and r. So this is p, this is q, and this is r. So p is the I component, q is the j component, and r is the k component. Alright, so we are differentiating r with respect to y. So first we need r with respect to y. So this is the r differentiating with respect to y. And remember, it's partial derivative. So we are treating the other constant as other variables as constant. So x and y are treated as constant over here. We're only differentiating y over here. So this is a constant, so we're left with x only because y was a constant. And now since we are already in r, so let's do another r then. Another r we have is x, r of x. So r of x. Let me write it at the bottom. Okay, r of x. So here we are treating x as a constant. So we're differentiating with x, and y is held as constant, and the derivative of x is just 1, so we're left with only y. right? Here y and z are constants. Okay, next, what do we have? We have q over here. So q with respect to z. So q with respect to z, that means differentiating only z. We're left with y, since it's a constant. And then now, what else do we have of q? We have q with respect to x. Q with respect to x. Q with respect to x, okay? And here, y and z are constants. So y and z are constant, we only have y and z, that means this is 0. Okay, next. What do we have next? We have r of x. We have r of x. Okay, so here this is r, we're differentiating x only, and y is constant, so this is y. Okay, and next we have, do we have something else of r of x? Oops, I forgot, I already wrote r of x. Sorry about that. Okay, r of x we already have. We're only left with p now. Okay, p of z we have over here. Okay, so p of z, we're differentiating only z, so this is x. And now we have p of y left only. P of y, this is 0, since x and z are constant over here, right? And these two are x and z, so this is constant, 0. And if you want, you guys can follow the order, like calculate r of y first, and then q of z first, and then r of x first, like go in order, so you guys don't make the same mistake like I did over here. Alright, let's continue. So now we have all the pieces needed to find the curl. Now the only thing needed is to plug in into the formula. So r of y, that's x minus qz. Where's qz? That's y I hat negative j hat r of x minus pz plus k hat q of x, that's a 0, minus p of y, that's 0 as well, so this whole thing is 0. So the curl of y is finally x minus y minus j, y minus x, and that is the final answer. Okay, and now this was only for curl of f. We still need to find the divergence of f. Okay, divergence. So let me explain how to find the divergence. Okay, so to find the divergence of f, you simply need to dot product the gradient with the function f, right? And the function f is in the form of pqr, remember? Okay, so the gradient of f is simply partial derivative with respect to x, I hat, partial derivative with respect to y, j hat, and partial derivative with respect to z, k hat, and dot producted with the function pqr. So we have p I hat q y hat or j hat plus r k hat. Okay, so now we're simply dot product it. So this times this, so then that would be p partial derivative of p with respect to x, and then it's this times this. Remember how you take the dot product, you only multiply I variable with I, j with j, and k with k, and there's no I, j, k at the end. It's gonna be a scalar product. Divergence is a scalar product, and curl is a vector product. Okay. Okay, so next we're going to multiply this times this. So that would be partial derivative of q with respect to y plus partial derivative of z with respect to, partial derivative of r with respect to z. Okay, r with respect to z, and this is how you're going to calculate the gradient. The divergence, or you can simply write this as p of x plus q of y plus r of z. And yeah, you need to remember this equation as well, but I guess you can simply remember this. It's quite simple to derive at this, right? So only remember that is gradient that divergence of f is simply gradient dot product with f, and you can simply derive this. It's not that hard. Okay, so for divergence we need p of x. Do we already have p of x? No, we don't have p of x. We had p of y, but we don't have p of x. So let's calculate p of x then. So p of x is equals to, let me use a different color for divergence. Divergence. Okay, p of x. So this is my p, and we're differentiating with respect to x, so that's only going to be z. Okay, and next we have q of y. Okay, q of y, so that's going to be q of y, that's going to be z as well. And then we have r of z, right? Yeah, r of z. R of z, this is going to be 0 because x and y are constant, and there's only x and y here, so this is 0. So this is z 0. Okay, so this is divergence of f is equals to, this is 0. Oh, I mean, sorry, this was z, not 0. Okay, z, and 0. So the answer to divergence of f is 2z. Thanks for watching. Bye. And I will provide the link in the description below to the notes, so you can download them out. Bye.